Hello and welcome to a new video on IGCSE Physics Classified Questions. Today we will be discussing the topic of magnetization as well as the topic of induced magnetism. We will begin by how to magnetize and demagnetize metal. So which action will demagnetize a magnetized piece of steel? Either hammering or heating or placing it in an alternating current. So this is obviously incorrect, incorrect, incorrect. Hammering is the correct choice here, choice B. Which procedure may be used to demagnetize a steel bar? Again, hammering, heating, or an alternating current. So the correct choice here would be choice C. The student suggests 3 methods for demagnetizing a piece of steel: placing it in an east-west direction and hammering it, placing it in an east-west direction and heating it, removing it slowly from a coil carrying an alternating current. These are all correct answers. So the correct choice is choice D. Which statement about magnetism is correct? An unmagnetized iron bar becomes magnetized when it is placed near a magnet. This is correct. An unmagnetized steel bar can be magnetized by passing a current through it. This is not correct. You can magnetize iron by passing a current through it, but you cannot magnetize steel because iron is made of soft magnetic material and steel is made of hard magnetic material. So B is incorrect. Steel is used as the core of an electromagnet. Again, this is incorrect. We said in a previous video, iron is used as the core of an electromagnet. When an iron bar has been magnetized, it is difficult to demagnetize it. Again, this is also incorrect because iron is very easy to magnetize and demagnetize, which is why we use it as an electromagnet. As soon as you pass electricity, it becomes a magnet. As soon as you stop the electric flow, it no longer becomes a magnet. So the correct choice here is choice A. A student demagnetizes a magnetized steel bar. He places the bar in a solenoid connected to a power supply. He then removes the bar from the solenoid. Which row indicates the most effective way of demagnetizing the bar? So it needs to be an alternating current, and you need to remove it very slowly from the coil. The correct choice here is choice B. What is the most effective method of demagnetizing a bar magnet? Again, hammering, heating, or an alternating current. So A says place the magnet in a solenoid carrying a large alternating current and gradually decreasing the current. B says placing the magnet in a solenoid carrying a large direct current and gradually decreasing the current. C says placing the magnet in a solenoid that produces a magnetic field in the opposite direction of the magnet. And D says placing the magnet next to an identical bar magnet with its poles in the opposite direction. So like we said, the ways to demagnetize a bar magnet are hammering, heating, and an alternating current. And of course, you have to gradually decrease the current or slowly removing it from the solenoid. So the correct choice here would be choice A. How can a permanent magnet be demagnetized? We've said this before. Correct choice would be here, choice C. An old and expensive steel watch becomes magnetized. The owner wants to use the watch again. He must demagnetize the watch. What is the best method to do this? Take a minute to read through the choices, and you will hopefully agree that the correct choice is choice A. This is a repetition of previous questions. What is the best method to demagnetize a steel rod? Again, so pass the rod through a coil connected to an AC supply, or pass it through a DC supply, or place it next to another magnet, or stroke it with another magnet. course, to demagnetize, you need to pass it through an AC supply. What do you use for the core of an electromagnet? You should know from the previous video that this is iron. B is the correct choice. A steel magnet is placed inside the coil of a wire. What method is used to demagnetize? They love this question, apparently. So which method is used to demagnetize the magnet? Connect to an AC power supply and slowly remove. B is the correct choice. How do you demagnetize a bar magnet? Hammering, heating, or an AC current. So here, heating it will be the correct choice. How do you demagnetize a magnet? Again, hammering, heating, or an AC current. So D is the correct choice. Which statement about magnetism is correct? An unmagnetized iron bar becomes magnetized when it is placed near a magnet. This is probably correct. B says an unmagnetized steel bar can be magnetized by passing a current through it. This is wrong because this doesn't apply to steel, it applies to iron. The direction of magnetic field lines is from the south to the north. This is incorrect as per our previous video. The north poles of two magnets attract each other, also incorrect because opposites attract and similars repel. So the correct choice is choice A. To magnetize, you place an iron bar near a magnet and then it becomes a magnet as well. A steel magnet is placed in a coil and demagnetized. Which type of current is established and how is the current changed? So it's an alternating current and reduced slowly to zero. So the correct choice here would be choice D. Moving on to a more difficult topic, or not necessarily difficult, just a little more stimulating because the previous topic was obviously very easy. Anyway, we'll be discussing induced magnetism. So you should know that when magnetism is induced in an object or in a metal, this metal becomes a magnet, and it has to have the opposite pole to the nearest pole that induced it. So if I induced it using a magnet and the north pole is closer to this piece of metal, then the edge of the metal that is close to the magnet has to have a south pole. We will see this repeatedly in the following question. Two nickel bars are placed close to the north pole of a bar magnet. The nickel bars become magnetized. So like we just said, this is induced magnetism. I've used the magnet to magnetize the nickel bars. So this has to be south. It has to be opposite to the closest pole of the actual magnet. So if this is south, then this has to be north. And then this nickel bar will magnetize the nickel bar next to it. So this has to be south, opposite to the N. And then this has to be north. So the correct answer here would be P is north, Q is south, and the force between them is obviously attraction, because opposites attract. So the correct choice here was choice A. A magnet is placed on a balance. The balance reading changes when an iron bar or another magnet is held close to the first magnet. Which row gives the balance reading in diagram 2 and in diagram 3? So bear in mind, we are holding the iron bar. So the iron bar is held in my hand. It cannot move. Similarly here, this guy is held in my hand, so it cannot move. So what happens in each case? So this one, let's start with diagram 3 because it's easier. We already know that the north and the south will attract. So there will be a force, an upward force on this magnet here. So it will be slightly pulled up. So what happens when it's slightly pulled up? I expect the balance to reach something less than 100, maybe 90 or something. Because an upward force is attracting the 100-gram magnet upwards. So it exerts less force on the balance, so the reading decreases. What about the iron bar? So again, this is induced magnetism. The iron bar becomes a magnet, and this again has a north pole here. So exactly the same effect happens. An upward force is exerted, and I expect a smaller reading in the balance. So the correct choice here would be choice A, less than 100 for both. In two separate experiments, a magnet is brought near to an unmagnetized iron bar. This causes the bar to become magnetized. So X has to be N opposite to this S. And here I have N, so I have S here, so I have N here. So X has to be N and Y has to be N as well. And the correct choice is choice A. Permanent magnet is placed close to a bar of soft iron. What are the polarities of end P and end Q? Again, we said for induced magnetism, this has to be opposite to the nearest pole. So this is S and this is N. So the correct choice is choice C. An iron bar PQ is placed close to a bar magnet. In which diagram does end P become an induced north pole? So let's check for each case. Here P becomes S because it's close to N, so this is incorrect. Again, P here becomes S, so incorrect because it's close to the N. Here Q becomes N, so P becomes S, so this is also incorrect. We want P to be the north pole. Here P is close to the S, so P becomes N, so this is the correct choice. D is the correct choice. The diagram shows a bar magnet at rest on a smooth horizontal surface. The length of soft iron wire is held parallel to the magnet. The wire is released. What happens? Obviously, like we said, with induced magnetism, we know that the close end to N is going to be S, and the close end to S is going to be N. So there's going to be a force of attraction because opposites attract. So the wire moves towards the magnet. Choice B is the correct choice. This is the end of our video. Thank you for joining. I hope this has been beneficial to you.